On September 5, 2027, humanity will commemorate an extraordinary achievement in the history of space exploration. On that date, Voyager 1, the farthest-reaching object ever crafted and launched by human beings, will have been traveling through the vast expanse of space for exactly 50 years. Its journey began with a single launch in 1977, and since then, it has defied the limits of distance, time, and human expectation. This silent traveler, born of scientific ingenuity and fueled by unshakable curiosity, continues to drift farther from home with every passing moment. As of that milestone, Voyager 1 will be hurtling through interstellar space at a velocity of nearly 38,000 miles per hour. It will be located approximately 176 astronomical units from the Sun, a staggering distance that places it roughly 24 light-hours away from our home star. To put that in perspective, a signal from Voyager now takes more than 20 hours to reach Earth, even traveling at the speed of light. And yet, this immense separation from its birthplace is merely the beginning of a far greater journey. If it remains untouched and uninterrupted by cosmic debris or gravitational anomalies, Voyager 1 will require an estimated 300 years to reach the innermost boundary of the Oort cloud, a spherical shell of icy objects that marks the distant edge of our solar system. Reaching the next nearest star system, however, is an entirely different endeavor, one that would demand a mind-bending 40,000 years to complete. Even then, it is unlikely Voyager 1 will pass close enough to any particular star to be captured or noticed. What lies beyond this enormous frontier? Where will Voyager go as it silently glides through the interstellar void, away from any star, planet, or observer? What phenomenon might it pass by in the eons ahead, and will it ever be discovered again? These questions are cosmic in scale and nearly impossible to answer. And yet, to understand Voyager's future, we must take a moment to reflect on its origin and the legacy of discovery that defines its existence. Voyager 1 was launched alongside its sister probe, Voyager 2, as part of a bold yet initially limited mission known as the Grand Tour of the Outer Planets. The goal was to use a rare planetary alignment to send the spacecraft past Jupiter and Saturn, collecting never-before-seen images and measurements along the way. Though this mission was initially framed with relatively modest expectations, the results would forever redefine our understanding of the solar system and our place within it. In March 1979, Voyager 1 approached Jupiter, the largest planet in our solar system. What it captured was unlike anything humanity had ever seen. Its cameras revealed the planet's dynamic atmosphere, marked by massive bands of swirling clouds and fierce, enduring storms. Most striking was the Great Red Spot, a colossal and long-lived storm system larger than the entire Earth. Voyager 1 also detected a delicate and previously unknown ring system encircling Jupiter, evidence of how even the largest planets possess unexpected intricacies. But it was Jupiter's moons that delivered the greatest surprises. On Io, Voyager recorded a surface dotted with active volcanoes, violently erupting and reshaping the landscape, an astonishing revelation that made it the first extraterrestrial body known to have active volcanism. In contrast, Europa presented a serene and icy surface, smooth and bright, suggestive of an ocean hidden beneath its crust. This discovery raised thrilling questions about the potential for extraterrestrial life in subsurface oceans far from the warmth of the sun. Voyager 1 continued onward and, by November 1980, it arrived at Saturn, the jewel of the solar system. The spacecraft transmitted breathtaking images of Saturn's iconic rings, which were far more complex than previously imagined. Voyager revealed thousands of tiny ringlets, gaps, and waves within the ring system. Among the most fascinating structures was the mysterious F-ring, a faint and twisting band whose behavior continues to puzzle scientists to this day. Of particular interest was Saturn's largest moon, Titan, shrouded in a dense orange haze and possessing a thick, nitrogen-rich atmosphere. Titan stood out as one of the most Earth-like bodies in the solar system, at least in atmospheric composition. Voyager 1's instruments suggested that Titan was home to a strange form of weather, and lakes of liquid methane and ethane on its surface. The detection of complex organic molecules hinted at chemistry that could one day lead to life or may have already. The success of Voyager's planetary encounters was monumental, but they were only the beginning. After its Saturn flyby, Voyager 1 began a new chapter in its voyage, the Voyager interstellar mission. This phase shifted its purpose from planetary exploration to examining the furthest boundaries of the Sun's influence, specifically the heliosphere, the immense bubble created by solar wind that envelopes our solar system. In 1990, Voyager 1 took its final photograph. As it looked back one last time at Earth, it captured an image now known as the pale blue dot. In this photograph, Earth appears as a tiny speck suspended in a beam of sunlight, a sobering and powerful reminder of our fragile place in the cosmos. Shortly after capturing this image, Voyager's camera systems were powered down to conserve energy for the instruments that would study the interstellar medium. By 1998, Voyager 1 surpassed Pioneer 10 to become the most distant object ever created by humans. Then in August 2012, it crossed a historic threshold. It exited the heliopause and officially entered interstellar space. In doing so, it became the first spacecraft to leave the protective bubble of the Sun's solar wind. Since then, Voyager 1 has continued to send back data about the magnetic fields, cosmic rays, and plasma density in the space between stars, valuable information that no other spacecraft has ever gathered firsthand. Despite its immense distance, Voyager 1 still communicates with Earth. Its 3.7-meter wide high-gain antenna sends faint signals back to ground stations on Earth, which are part of the Deep Space Network, a system of antennas located in California, Spain, and Australia. These facilities receive signals from Voyager more than 20 hours after they are transmitted, owing to the sheer distance involved. Each transmission is a whisper across a cosmic gulf, a fragile thread that still connects us to this ancient explorer. Voyager 1 is powered by radioisotope thermoelectric generators, RTGs, that use the heat from the decay of plutonium-238 to generate electricity. However, the energy output from these generators diminishes over time by approximately 4 watts per year. It is projected that by 2025, the spacecraft will no longer have sufficient power to operate its instrument or transmit data. When that moment comes, Voyager 1 will fall silent, its voice lost in the endless night. It will become a ghost ship, drifting endlessly among the stars. Yet, even in that silence, Voyager will continue to carry a trace of humanity. On board is the Golden Record, a 12-inch gold-plated copper disc that serves as a time capsule for the stars. This carefully curated artifact contains greetings in 55 languages, along with a selection of Earth's sounds, music, laughter, nature, and human voices. It is a message in a bottle, cast into the cosmic ocean, a declaration that we once lived and reached for the stars. The ultimate fate of Voyager 1 is uncertain. If it is not torn apart by micrometeoroid impacts or degraded beyond recognition by cosmic radiation, it could survive for hundreds of millions or even billions of years. But over those vast timescales, the galaxy itself will change. Stars will drift, constellations will dissolve, and new ones will form. Voyager may be tugged by the subtle pull of gravity across the Milky Way. It might one day pass through dense star clusters or drift into the far galactic halo, remaining unseen by any intelligent being for the remainder of time, though it is unlikely to be intercepted by any alien civilization or chance upon another world. Voyager 1 carries within it something greater than its scientific instruments. It carries our curiosity, our hope, and our longing to understand the universe. It is a symbol of human boldness, of our refusal to remain bound by Earth's gravity and our urge to seek out the unknown. In the end, the importance of Voyager 1 does not lie in how far it travels, but in what it represents. It is the first human voice cast into the void, the first glimmer of our light extended into the cosmic dark. And perhaps someday, somewhere, in the deep and silent spaces between the stars, another form of life will find it and listen. Voyager 1 reminds us that we are a species capable of dreaming across centuries and reaching into the stars from a fragile blue world. Its journey is not only a mission of science, it is a testament to our shared story, our place in the cosmos, and our enduring will to explore.